Let's take a look at this problem. We got f of x is equal to x plus 6 over x squared plus 3x minus 18. Now, we gotta take a look at the continuity first, and we'll look at the graph. Again, we find out what's discontinuous, so we set our denominator equal to 0. X squared plus 3x minus 18 equal to 0. And I can factor this. This is x squared x, no number in front of our x squared. So this is a PST. Take our number at the end, the 18, ignoring the sign. Come up with our three columns. We got 1 times 18, 2 times 9, 3 times 6. S column, add these together. 1 plus 18 is 19, 2 plus 9 is 11, 3 plus 6 is 9. Subtract them, the difference column. 18 minus 1 is 17, 9 minus 2 is 7, 6 minus 3 is 3. Number we're looking for is a 3, the number in the middle term, which is right here. So we're going to use 3 and 6. Okay, our larger number in the P column we're using, which is a 6, is always going to be the same sign as the middle term, which is positive. Number I circled in the difference column, D for different signs. So if this one's positive, this one has to be negative. Zero factor property. It says you get 0 on one side, you factor the other side, you can set each factor equal to 0. So I'll set x minus 3 equal to 0 and x plus 6 equal to 0. And solve these, and we get x equals 3 and x is equal to negative 6. This is where it's discontinuous, cannot equal these values. So for a continuity, x cannot equal to negative 6 and cannot equal to 3. Now let's look at the graph. In order to graph this, we have to put parentheses around the top, parentheses around the bottom. Anytime you have more than a single number or a single variable on top or bottom, you have to put parentheses around it like that. So I'm going to press my y equals, clear, beginning parentheses around the top part, x plus 6, closing parentheses, divided by, beginning parentheses around the bottom part, x squared plus 3x minus 18, closing parentheses, and then graph. Now we got 1, 2, 3, 4, 3 I guess. 1, 2, oh, 3, yeah. It's we said it's discontinuous at x equals 3, and we see we have a gap at 3. So we got a gap in our graph. Oops. So let me sketch that. Okay, let's something like this. And something like that. Okay, now we said it's discontinuous at 3, and that's pretty obvious. You can see there's a hole right there. There's nothing there. But we also said it's discontinuous negative 6. Well, if I come over here to negative 6, what we're going to find is that there's going to be a hole right here. How do I know that? Well, if I come up here, and I got x plus 6, and we said this factors as x minus 3 times x plus 6. You see how the x plus 6's cancel away and are gone? Which means this x plus 6 here would have disappeared if we had factored and canceled like that. When it disappears, there's actually it's still discontinuous there, but it's a hole. So there's an open dot, open point there. But that would be our graph.